We are going to be continuing multiplication of radicals. We'll have the distributed property, FOIL, a representative box method. We've shown that a couple times. We'll get into special products, and then there's shortcuts that we can take with depending on what type we have. In 090, when you've worked with the polynomials, the product rule of exponents became a mainstay. If you had x times x, it would become x squared. You'd add the exponents. X squared times x cubed, 2 plus 3 would be 5, x to the fifth. It was a main part of everything we did here in terms of polynomials. The product rule of radicals, if the indexes match, multiply the radicands, is a mainstay of what we're going to do here. So we're going to go through and we're going to start with distributed property. That property doesn't change, but how we approach the radicals, well, it's not going to change. It's just we have to remember indexes match, multiply the radicands. Okay, so let me grab my notes here. Okay, so if we had something like this, the instructions on this generally are perform the operation and simplify where possible. Sometimes I'll say multiply. You can follow the order of operations. You can look inside the parentheses, see if there's anything we can simplify. As you distribute, you kind of take care of that parenthesis, so you got a little bit of leeway there. Remember, if it's outside a radical, it's treated as a coefficient. So a very basic guideline. Coefficient times coefficient, radical times radical. So right now, the coefficient here is a 1, coefficient here is a 1. So when I look at this 2 is outside, it's going to stay outside. So coefficient times coefficient, 1 times 2, I get 2. Square root of 3 times the other radical, but I don't have another radical. So it's 2 square root of 3. Now that's that distribution. Now I have to remember to distribute it to here. Square root of 3 times square root of 8. 1 times 1 is going to be 1. Square root of 3 times square root of 8 is square root of 24. Now yes, you could plug this into a calculator and spit out a decimal value, but that's not what we're going to look for. We're looking for a simplified radical. Now we're emphasizing and building on the adding and subtracting of like radicals. They have the same index, but are they like radicals? Only if the radicands match, which right now they don't. So this has a radicand of 3, this has a radicand of 24. There's nothing I can do to break down 3, but there might be something I can break down 24. Most of the ones we stick with the FOIL, the distributed property and such, we're going to deal a lot with square roots and cube roots. We don't do much in terms of the other roots. We kind of focus our process on those. So divide by 2 squared. 24 divided by 4, or 2 squared, goes in 6 times. So power matches the index, take out the base. So we get 2 square root of 3, take that 2 outside. Remember, when we take that item out, we don't move it in front of this plus. This is a product. It still has to be a product. So when we move it outside, we time or multiply it to whatever's out front. So that's a 1. So 2 times 1 is 2. The 6 stays inside. So when we look at this, indexes match, but the radicands don't. We cannot make these be like radicals. So we cannot combine them further. So this is as far as we can go. Now you could have it 2 square root of 6 plus 2 square root of 3. The order won't matter for those. Let's try this. Okay, so I've got square root of 2 times the quantity, the square root of 28 minus square root of 18. Remember, we do not add or subtract radicands. We do not add or subtract radicands. So we can't do 28 minus 10. We cannot do that. We could simplify. We could do the process we just did here on 28. We could do that process on 18 and then distribute and go from there. to me, if I know I have to distribute something, I could have simplified and then have to distribute and then I have to simplify again. Generally, I do the distribution first. Square root of 2 times square root of 28, I get the square root of 56 minus square root of 2 times square root of 18. Now the indexes match on these, so we can do this. We get the square root of 2 times 18 is 36. Okay, well, let's start here. Square root of 36, I know that to be, well, that's 6. I can evaluate that. Now, if I want to be able to combine that 6, this has got to be a whole number. If it's not a whole number, I'm not going to be able to get it down to one item. So in 56, is there a perfect square? Well, you start dividing by 4. 4 goes in 14 times, so 4 is 2 squared. So we're going to take a 2 out. So I'm going to get 2 square root of 14 stays inside. Now 14, I would look to see if I could simplify further, but 14 is 1 and 14, 2 and 7. There's no perfect square in there. So minus 6. Okay. So if that had been a perfect, come out to be a number, we'd be able to simplify further. We could also have negative 6 plus 2 squared root of 14. All right, let me do one more here. Okay, so actually, okay, so when we look at this, now again we're going to build on, mostly it's square roots we'll see, but we can't have cube roots. We will not have mixed. We won't have a cube root and then a square root. Okay, index is all matched, so we can worry about working on our product rule distribution. So it's still a distributed property. Now I could have 2 items like I have here. I could have a 3rd item in there, a 4th item. Remember, we have to distribute this item to all 3. So if I distribute, I get the cube root of 6 times 12 is 72 plus 24 times 6 . Cube root of 144. Now, some will say, hey, that's a perfect square. That is a perfect square, but we have a cube root, so we can't say that's going to be a 12. So as we go through, remember, when we start breaking things down, when it's a square root, I divide by perfect squares. When it's a cube root, I want to divide by perfect cubes. So I would start dividing into this, if I can, by 8. Well, and I know 8 is 2 cubed. It goes in 9 times. Now 9 is not a perfect cube, so I can take a 2 out. That 9 stays behind. In 144, can I divide by 8? I can. 2 cubed is 8. I know I can divide by 8 because I can divide 8 into 24. That's part of what we had. So I would have 8 times 18. 18. It's not divisible by 8. The next perfect cube would be 27, so there's nothing I can take out there in terms of the 18. I can take out 2 out there, so I get 2 cube root of 18. Indexes match, but the radicands don't. And I cannot break these down to get to be the same. Radical. So that's as close as we can get. Okay. In the next clip, we will get into FOIL, and we'll build on that.